As teachers of science, one of the things that we're always trying to get our students to be able to do effectively is to design their own experiments. And when I undertook this teaching middle school students, having 150 or more students, I found it to be a great challenge. So this particular activity has really helped me to be able to teach them the concepts of a control and an experimental group and an independent-dependent variable, and to keep those concepts flowing throughout their experiment. Here's the way it works. This paper, which I'm going to tell you where you can locate it at the end, is how we start. And we start by having students brainstorm together. So whatever general topic you want to brainstorm, often in my illustration I use something dealing with exercise. And so I tell the students to think of things that as a scientist they could change or vary on purpose regarding the topic of exercise. And they come up with things like they could change the type of exercise, the quantity of exercise that is done, the gender of the exerciser, and the intensity level of the exercise. And they each have this paper and are filling it out as they go with their sticky tabs. And then the other thing that I ask them is to think what a scientist could measure or observe that is different from those things above. And they come up with ideas like heart rate, respiratory rate, blood pressure, and calories used. And I get them to narrow their ideas to ones that we could actually test in class. Then I ask them to choose one for the next page that's going to fit and be the part that they want to change. So they might change, for instance, the quantity of exercise. So I have them take their sticky tab from the first page and move it over here. And then I tell them to change one that they want to measure or observe a change in. And they might do something like heart rate. So I move that sticky tab over. And then I say, okay, those are the two that we've chosen. That's going to become our independent variable and our dependent variable. But all of these others that we had, we want to make sure we try to leave those the same as much as possible. So let's take those sticky tabs and we'll put them over here in the section that we want to try to control as much as possible. And so they transfer their sticky tabs over, and that's the brainstorming section of the process. And now we start in on the actual scientific method. And it's really important that we emphasize that the scientific method isn't a certain number of steps that are etched in stone, but it's a process, and this is just one format that I have found that works, the one that I'm presenting. Okay, so here we go. And the step one in my method that I use is a problem question. So I get them to take their sticky tab, that was the independent variable they chose, and put it right over here. And I get them to take their dependent variable and transfer it right over here. And then I get them to turn their independent-dependent variable into a problem question. So how does the quantity of exercise affect the heart rate? And they can fill that in. And then the next step that I try to teach students is they need to do a little research or background information if they're going to come up with a educated guess for their hypothesis. And so we brainstorm things that they can research in their background information. The next step is creating their hypothesis. So I have them transfer their independent variable and their dependent variable over here, and they come up with an if-then statement. If the quantity of exercise is increased, then the heart rate will, and they can choose increase, decrease, or stay the same. Then we go to our next step, planning the experiment. And it's laid out, and I guide them into doing step-by-step instructions for that. Okay, and then once they have their experimental plan in place, they need to create a data table. And so we take our independent variable, quantity of exercise, and our dependent variable, and we create a data table for that. And then we also need to have a graph to graph our information. And so our independent variable is going to go here. Our dependent variable is going to go here. And a real handy little trick that I tell them is to take their left hand with their thumb representing the independent variable because their thumb is out there independently. Their fingers are representing the dependent variables. And they're going to put their items on the graph in that way, which I've got these backwards, so I'll switch them real quickly. So independent variable here, dependent variable there, and that works to help them to remember how to define those terms also, and you'd use them up in your title. Okay, so after we have that, we want to write a conclusion, and I have guided them in 6 steps that I like to see included in the conclusion. And then what you always want them to be able to do is go from there, whether their hypothesis was supported or not supported. They need to be able to figure out new designs that they could do. So they could take quantity of exercise, but they could vary something different. Like they could go back to their original sheets and they could measure possibly the respiratory rate, or they could change the gender of the exerciser and see how that compared to respiratory rate. And so from this framework and process, I have been able to guide 150 plus students without losing my mind in experimental design. So I hope it's a process that helps you. I actually have a web address where these things can be found, but in the description section of this video, I have posted the complete directions on how to find this on this experimental write-up online.